This is a new video on the classification using logistic regression, but on a new data which is the Cleveland Heart Disease Dataset. The link of the dataset can be found here. There are 303 patients and 13 predictors, which is age, sex, cholesterol, and we have to predict whether the person will have heart disease. So 0 means no heart disease and 1 to 4 indicates the presence of heart disease. So first is that I will import a library called warnings. This will and set it to ignore. That means all the warnings will be suppressed. Next, I will read my data set. It is the pandas data set and I will read it from the file path. This path you have to set it to your location of the file. This file we have given already to you. You will find the link to download this in the contents of the internship and training. Okay, so before this video there may be a link somewhere that says download the dataset for Cleveland Heart Disease classification. Then I read the dataset and I find that there are missing values, so I replace the missing values and I drop them. Since there are only 6 missing values, I will not impute them, which is another long procedure. I prefer to drop them. Then I divide my data into X and Y. The last column is the classification, other columns are the features. So this is the meaning of this ILOC, that take all the rows and all columns up to the last, whereas take all rows and take the last column. Once we have X and Y, I am converting the data set into binary classification. Okay, so only whether heart disease is there or not. So wherever there are other labels 1, 2, 3, 4, I am replacing them with 1. In Y, if you recall, there are 5 values: 1, 0, 1, 2, 3, 4. 0 means no heart disease, 1, 2, 3, 4 are heart disease. So 1, 2, 3, 4 I am replacing it with 1. That means my data will become binary data. Then just to confirm whether it is binary, I check the value counts. Further, I import the logistic regression and train test split. I split my data set by stratified sampling into 80%, 20%. Then I apply the standard scaler. So this is the common step, since there is no non-numeric data. So we no need for encoding. There are no duplicate values as per the documentation of the data set. Next comes the grid search. So I create a parameter grid and I apply grid search. Once the best estimator is found, I use that to predict on the test set and I calculate the F1 score for the predictions. Similarly, I can go ahead and calculate accuracy score, classification report, confusion matrix. Even I can calculate the ROC curve display. Okay, so to find out how well is the model doing. So that I leave to you, and this, to save time, I am not coding this with you. I am just telling you the steps. The steps are same, only there are few changes in the pre-processing. Remember that pre-processing is the only part that is different for the data sets. Different data sets may require different pre-processing. Other steps are standard steps. Already we have summarized before, so if you don't recall the steps, go to the previous videos and watch them again. Okay, so this task I leave to you. Calculate the accuracy score, calculate the ROC curve, calculate the ROC-AUC, calculate the confusion matrix, calculate the classification report. Okay, and this will give you ample practice of coding. So try on this data set and hope you are able to do it.